10.8b, Law of Cosines. Warm up. Solve the triangle and find the area. We're just going to solve the triangle. If you want to find the area, just for time's sake today, just going to solve it. So I notice that this is a non-right triangle, but what I do notice is that there is a match between angle E and side E, which means that I can use the law of sines. So let's do our match. So the sine of 109 matches to side length 11. And then we would want to use the other side length, and it matches to angle F. So we would want to find the sine of angle F, which corresponds to side length 8. We're going to cross multiply, so 11 sine of F equals 8 sine of 109. Divide by 11, so the sine of F equals 8 sine of 109 divided by 11. And then we use inverse sine to help us get this value of, get the value of F. So it's going to be the inverse sine of 8 sine of 109 divided by 11. And when we type this in our calculator, the inverse sine of 8 sine of 109 divided by 11 is approximately 43.4 degrees. So this angle F is 43.4 degrees. Then we can use our knowledge of 180 to get the angle D. So 109 plus 43.4 minus 180 leaves me with 27.6 degrees for angle D. And now I have an angle that can match with side length D, which is the missing one. So use our same match as before, sine of 109 divided by 11. And then now I have the sine of my new angle measure that I calculated, 27.6, over our missing side length D. Cross multiply, so D times sine of 109 equals 11 sine of 26, and we're going to divide off the 109, so I'm going to do it all in one step. So D equals the 11 sine of 27.6 divided by the sine of 109. And when you punch that into your calculator, that means side length D is approximately 5.4. Okay, so what happens if you don't have a match? Say you're working with a non-right triangle, so this is outside of the right triangle realm, but you do know a side with an included angle and another side. So say you knew side length C, angle B, and side length A, which doesn't have a match. We would really want angle B to match with side length B. So this is going to fall under a new case, which is called Law of Cosines. So you can use the Law of Cosines when you have a SAS case, a side angle side, or you can use the Law of Cosines when it's side, side, side. So this formula is developed actually in conjunction with trigonometry and Pythagorean theorem together. If you'd ever like to see the proof of how this is formed, I can give it to you. There are many little explorations that you can do online. But the three formulas are very similar to each other. If you memorize just one of them, the other three fall out from the one. So this is what it looks like. It looks like the beginning of it is Pythagorean theorem. So a squared equals b squared plus c squared. Obviously the c squared is normally on the third, so it looks like the Pythagorean theorem. Then you subtract 2 times these two values. So 2 times b times c. And finally, you do the cosine of the angle that you would like to create a match with. So in this case, it would be the cosine of angle A. And you can put it in parentheses if you want. So the beginning is Pythagorean theorem minus 2 times the values cosine of the angle measure that matches. So follow that pattern. So we've got b squared equals a squared plus c squared minus 2ac, those two values, cosine of the b value, the b angle that matches your b side length. Again, a squared plus b squared minus 2ab cosine of c. Now, how do you use it? So let's try these examples on. So this is the SAS example, a side angle side. So how you use this is that you would like to have a match. If you could have a match between 34 and B, you could use law of sines to finish solving this triangle. So right now, we have to use law of cosines because there's no match. So that's how I know it's going to be law of cosines. There's no match between an angle and a side. But we would like side length B, so we can use this formula here because we want side length B. So it's going to be a B squared. A is the one opposite of A, so 11 squared plus C squared, 14 squared, minus 2 times 11 times 14, and then the cosine of B, which is 34. So all of this on the right-hand side is all numbers. So really what we're doing is simplifying this down to a nice value that we can take the square root of, because eventually I want to undo B squared. So let's just work on simplifying. So just do it one piece at a time. 11 squared is 121. 14 squared is 196. 2 times 11 times 14 is 308. 121 plus 196 is 317. So now we've simplified it down to an expression that's not very difficult to get a decimal for. So then we can bring our B squared down. So B squared equals, and then type this into your calculator, and you should get 61.656, and I'm just going to take 3 decimal places right here. Then you can take the square root of that and get B to be approximately 7.852. Which seems reasonable. It's less than 11 and less than 14, and it's between the two sizes, so that seems reasonable. Let's try using it when it's a side, side, side. So on this one, we only have all 3 sides. It's not a right triangle, so we know we have to use law of cosines in order to get an angle. But in this case, the last step of this problem is not going to be a square root like it was before. It's going to be inverse trig, because we're going to get an angle measure. So the cool part is that you can pick whichever angle you would like to go for. So let's just pick angle A. Why not? And we can look up at our formula options. We want to use the one that's going to calculate angle A. So we're going to use this first one, A squared, B squared, C squared, and the cosine of A. So then this would be A, this would be B, and this would be C. So then we've got 12 squared equals 27 squared plus 20 squared minus 2 times 27 times 20 times the cosine of A. So now our missing value is not the side length. We know all 3 side lengths, but I don't know the angle measures. So our last step is going to be an inverse. Again, just simplify real slow. So 12 squared is 144. 27 is 729. 20 squared is 400. 2 times 27 times 20 is 1080. Cosine of A. Keep simplifying. Let's do those 2 together. So 144, 729 plus 400 is 1129. Oops, 1080. Now we're trying to get to the cosine of A, so the first thing we need to pull off is this 1129. So subtract 1129 from both sides. So now we've got negative 985 equals negative 1080 cosine of A. Now we need to take the negative 1080 off, so divide by negative 1080. So then negative 985 divided by negative 1080 is a 0.91203, and that's just taking a couple of decimal places. Cosine of A. And then finally, to get to this A, this is where we take an inverse. So the inverse cosine of 0.91203 is approximately 24.21 degrees. And then you could work from there because now you have a law of sines match. So you've got that side length 12 that matches your angle 24.21. So now what we'd like to do is bring all of our tools back together in our toolbox. So we've got a lot of tools. We've got Pythagorean theorem, trigonometry, inverse trigonometry, special right triangles, similar right triangles, and now our two new friends, law of sine and law of cosine. So let's start with our familiar friends up top. Something that you should note is that these first, so Pythagorean theorem, trigonometry, inverse trigonometry, special right triangles, similar right triangles, but not law of sines and law of cosines, all of these, so I'm going to kind of turn my paper sideways here, all of these require the knowledge of a right triangle. You must have at least one 90-degree angle to use any of those tools. Pythagorean theorem, trigonometry, inverse trigonometry, special right triangles, similar right triangles. But these last two is any triangle. Does not have to be right. So law of sines and law of cosines are used for non-right triangles. So how I'd like to format this is what do you know and what do you want? So for Pythagorean theorem, we know two sides. What do we want? Want a third side. A squared plus B squared equals C squared. Trigonometry. Trigonometry is SOHCAHTOA. What do we know? We know one side, one angle, and we want a side. Inverse trig. Inverse trig, it looks like this. And it spits out angles. So for inverse trig, you need to know at least two sides, and it gets you an angle. All right, special right triangles. So the first one is a 30, 60, 90. Let's draw a picture. So this is our 60, our 30. So if this is x, this is 2x. This is an x root 3. Our second special right triangle is a 45, 45, 90. So these two sides are congruent, x and an x root 2. Similar right triangles is when you have an altitude and you want sides. So that's one that looks like this. So this overall triangle is right, and it's got an altitude. This is the big, medium, small. All right, law of sines is when you have a match between a side and an angle. And the law of sines is sine of A over A equals sine of B over B equals sine of C over C. Law of cosines is brand new today, so you need to know either SAS or SSS. And you're looking for a side or angle. And let's just write one of them. A squared equals B squared plus C squared minus 2BC cosine of A. Thank you.